How did reinforcement learning evolve to deep RL? Imagine teaching a dog to fetch or a child to ride a bike. Both learn through trial and error, getting rewards for good actions. This idea is at the core of reinforcement learning. Reinforcement learning started from psychology, where behaviors are shaped by rewards or punishments. Early thinkers like Edward Thorndike and B.F. Skinner showed that actions followed by positive results are more likely to happen again. These ideas laid the foundation for machines to learn by trying different actions and seeing what works. In the 1950s, mathematicians like Richard Bellman created dynamic programming. This was a way to solve problems where decisions depend on previous choices. It helped computers figure out the best way to do something step by step. Later, in the 1970s, Richard Sutton introduced Monte Carlo methods and temporal difference learning. These techniques let machines learn from experience without knowing everything about the environment upfront. They could estimate how good certain actions were and improve over time. As reinforcement learning grew, it faced challenges with complex environments. Traditional methods struggled when there were many possible states or actions. Then, in the 2010s, a new approach emerged by combining reinforcement learning with deep neural networks. Neural networks are computer systems inspired by the brain that can learn from large amounts of data. This combination created what we now call deep reinforcement learning. The first big success was the DeepQ network developed by Google DeepMind in 2015. It used a neural network to learn how to play Atari video games directly from pixels. This was a huge step because it showed machines could learn complex tasks from raw data. DeepRL also helped create programs like AlphaGo, which mastered the game of Go by combining neural networks, reinforcement learning, and advanced search techniques. Since then, deep reinforcement learning has been used in many areas. Robots learn to walk and pick up objects. Self-driving cars make decisions in real time. Language models like ChatGPT use similar ideas to understand and generate text. Image generators like DALL-E and Midjourney also relying on deep learning techniques that evolved from reinforcement learning principles. From an ethical point of view, deep reinforcement learning raises questions about transparency and safety. These systems can sometimes behave unpredictably or make biased decisions. That's why researchers and developers focus on making these models more understandable and safe to use. In short, reinforcement learning evolved from simple ideas about reward-based learning to complex systems that use neural networks to solve real-world problems. This journey has made AI smarter and more capable, opening up many new possibilities for technology and society.